Okay, I set you up for the Reading Rainbow song, that's all. Take a look, it's in your book. Reading Rainbow. All right, anyway, here we go. So we are, sorry, page 45. Page 45 is where we are. We are going to look at today beginning to translate in math class. Taking English words and ideas and translating them into mathematical relationships or representations. Okay, and so we're going to start out kind of basic, and then we'll make our way, okay, to some more advanced stuff too. This causes people problems, okay, and I get it. You're taking one language, English, right, and then you're putting it in terms of mathematics, okay. We're able to solve equations, but setting up equations can be kind of difficult sometimes. Anywho, though, let's read through some of this here. Okay, we'll start out, like I said, kind of basic. So, an expression, we've heard that before. Okay, an expression is a mathematical phrase that contains operations like add, subtract, multiply, divide, numbers, we know what those are, and/or variables. Easy. The terms of an expression are the parts that are being added. So, terms are separated by addition. A coefficient is the numerical factor of a variable term. That's just the number in front, right, of the term. There are both numerical expressions and algebraic expressions. A numerical expression contains only numbers. Hey, that makes sense, right? And algebraic expressions contain numbers and at least one variable as well. Okay? So, let's look at letter A here. Identify the terms and coefficients of the expression 8p plus 2q plus 7r. Okay? So, someone want to raise their hand? Give me a term here in the expression. What do we got? Sky, what's one of the terms here? 8p is one of them. Okay. Who's got another one? What's another expression? Go ahead, Erica, you got one? 7r is another one, and we got one more. What's the last one there? Very good, Erica. What's the last one? 2q. Okay, exactly right. So those are our three terms, all separated by addition. Okay? Alrighty. What are the coefficients that we have in this expression? What are the coefficients? That is, what are the numbers in front of those terms? So what are our coefficients here? Carson, you got an idea? 8's one of them. Okay. Let's go to... Go ahead, Alex. 7 and 2 then are other ones. Yep, exactly right. Okay. And you put them in the same order as the terms, which is good. Didn't have to be that way, though, but that's okay. Okay, now, letter B. Identify the terms and coefficients of the expression 18 minus 2x minus 4y. Okay? Since the expression involves blank rather than addition, what do you think goes in the blank there? Since the expression involves blank rather than addition. Subtraction, right. The expression here has subtraction. Okay? So since the expression involves subtraction rather than addition, rewrite the expression as the blank of the terms. And we're going to say sum. Okay? So we're going to rewrite as a sum instead of subtraction. So how can I rewrite 18 minus 2x as a sum instead of a difference? Instead of minus a positive 2x, we can do 18 plus what? What's the same thing as minus positive 2x? We can instead add a crickets? Yeah, Ben?
Never mind.
Never mind. Instead of subtracting a positive 2, we can instead, and same thing, add what? Negative 2x. So I'm going to make this minus 2x a negative 2x, plus negative 2x. And instead of minus 4y, we can make it what? Plus, not positive 4y, negative 4y. Like that. Okay? And now it makes it easier for us to see the terms. Okay? Now it makes it easier for us to see the terms. So let's see here. Reagan, what's one of the terms in here? In the expression. 18. That's one of them. What's another one? Negative 2x. Yep, you want to put it all together because it's together inside the addition symbols there. And what's the last one?
Negative 4y.
You got it. Good job. Okay? Very good. And so then, Mark, what are the coefficients of these terms? Okay, so Reagan gave us the three terms. What are the coefficients there, Mark?
There is
Just give me the numbers. One of them is 18.
and -47.
Negative, oh, that's a y, sorry. So negative 4. And what's the last one? Negative 2. Not the x, just the numbers in front of the coefficients. Okay, coefficients are the numbers in front. So 18, negative 2, negative 4. Okay, good job. All right, next here. Tickets to an amusement park.
I have a question.
Oh, question.
So
Oh, I
the
missed
18
one.
does not have a variable. So
18
why is
does
that
not.
a coefficient?
It's a coefficient. Oh, let me see here. I see what you're saying. You're right. It's not a variable term. You're right, Ms. Mulcahy. We probably should not include that because it did not have a variable with it. So only the negative 4 and the negative 2. Right, because it says here, didn't read that, numerical factor of a variable term. 18 is not a numeric and is not a variable term. Okay. Well, good. We fixed that. All right, I think we get the idea. We're going to skip letter C. Why don't you guys go ahead, okay, and let's see here. Can I skip to? All right, no, let's do this tickets one here, and then we'll maybe move on, okay? So tickets to an amusement park are $60 for adults and $30 for children. If A is the number of adults and C is the number of children, then the cost for A adults and C children is 60 times A plus 30 times C. Okay? So, what are the terms of the expression here? Well, let's go to, come on, there we go. Let's go to Liv again. What are the terms of this expression, the 60A plus 30C, Liv? 60A, and what else? And 30C. Okay. Okay. All right. This one's a little bit confusing here, but I think what they're shooting for is, what are the factors of 60A? I think they're looking for 60 and A, and the factors of 30C are 30 and C, I think. Although you could really divide 60 by many numbers, right? 12, 10, 6, but I think they're looking for just 60 and A there. Okay? And then, what are the coefficients of the expression? So what are our two coefficients here? Anybody? 60 and 30. Very good. Okay. So again, we're just kind of breaking things apart here, identifying things, making sure we can understand the different names for things. But last, this is the most important. Interpret the meaning of the two terms of the expression. So for example, Liv identified 60A as one of our terms. What does this represent in the problem? Adults. Okay, what about the adults? Is it just number of adults? It's what they have to pay. Exactly right. So 60A is the cost for the adults. Because there's A adults that went times 60 for the number of tickets. And then what's the 30C going to represent then? What does 30C represent? Kids. What about the kids? Cost. Yep, cost for the children. Okay. And if this is super easy for you, great. Okay, great. I hope so. Okay, but I just want to make sure we're all good here too. Okay. All right. Why don't you guys go ahead then and try this next one that deals with the price of a case of juice is $15. Read that and then answer I through L. Okay, I through L. So start here and then go on, I through L. Okay? So I, J, K, L on the next page there. Okay? So go ahead and answer those questions as best you can. You can skip J if you want to. You know what? You can skip J if you want to. So feel free to just cross out J. Okay? Feel free to just cross out J there. But then try, so I, K, and L, please. Just I, K, and L. Give those a try. Okay? You got this question? Yeah. Let's go ahead and answer those questions, and then we'll call on some folks to answer. Yeah, we may skip J. Just because I think it's a silly question, I think. It is a silly place. Whoops. Out here, right? What's that? What's the question? You're not sure what it is? Okay. So, affirmative terms. So if you look here, there's your expression. But to find terms, we need addition. So instead of writing minus 0.2b, we need negative plus negative. So there are two terms. And what are your terms? Negative 0.2b is your other, those are your two terms. No, no need to solve. Just identify the parts right now. We'll get to the solving in a bit. Okay, yeah, that could work. I see what you're saying there. I took it to mean a different thing, but I think that's not, I don't think that's wrong. Yeah, that would be fine, I think. Question? Eric, are you doing okay?
Yes, I answered that question.
Yes. Okay.
So what, you got B too?
You can skip J, yeah.
Okay.
Yeah, you're feeling good on stuff, yeah. Okay, anyone still working? Miss Mulcahy, you guys good to move on?
Yeah, we're good.
Okay, so let's take a look here. So letter I, two terms, 15 and negative 0.2b. Remember that in order for something to be a term, you have to have addition separating it. So I changed that 15 minus 0.2b to be 15 plus negative 0.2b. So there's two terms. Treat that as a negative one there. Okay? Moving on. Letter K. Do both terms have coefficients? No, right? What we talked about earlier, no. Only negative 0.2b does because it has a variable. What are the coefficients? Well, just the negative 0.2. Okay? That 15 doesn't have a variable, so it's no coefficient. Excuse me. And then letter L, and you might have written different things here. So here I wrote the letter L. This expression means it's the amount of money Fred will pay for the case of juice at the end, right? Okay. But there are other good ways to say this too. So in fact, Carson, do you mind sharing yours real quick? What'd you write?
$15 for a case of juice and 20 cents off each bottle of weed.
Right, so that's a good way to write it too. He just wrote it as $15 for the case of juice and then 20 cents off per bottle. Okay, kind of thing. So it depends on the number of bottles and stuff like that too. All right. So, let's get into then some more kind of this interpretation. So we'll go down here to letter A, okay, and we're actually going to then keep interpreting here. So letter A, all right, we're told Curtis is buying supplies for his school. He buys P number of packages of crayons at $1.49 per package, and Q packages of markers at $3.49 per package. What does the expression 1.49p plus 3.49q represent? Okay, and so it kind of breaks it down into pieces here. What's the meaning of the term 1.49p? What does it mean? 1.49 times p. Well, what does the coefficient 1.49 represent? Anybody? What we just read. From what we just read there, what does $1.49 represent? The price per package of what? We have two objects we're talking about here. Crayons, right, okay, that's right. And then, so it says it right there, right? And then what does then 1.49 times P represent? Okay, right, we don't know how many, but what does that give us? When we do 1.49, the price of a single package times P, that's going to give us the total amount, total quantity for how much we spend on the crayons, okay? What does the 3.49 represent? What's 3.49 represent in this problem? Let's go to, well, how about Matt T? What's 3.49 represent?
The price package.
Price or package of what?
How many you buy?
Of but what? What's he buying? For $3.49.
Crayons.
Not crayons.
The other one.
Yeah.
Yeah?
Yeah.
He's buying yeah?
Oh, markers.
Markers. Okay, markers. That's right. Okay, so. So if we take then 1.49p and then 3.49q and we add them together, that's then the what? That will be what? Total amount, total cost. Exactly right. It says it right there. The expression 1.49p plus 3.49q represents the total cost of p packages of crayons and q packages of markers. All right. Maybe I'm making this too hard. I'm not sure. Let's maybe skip to some problems here and see what we can come up with. Okay? Maybe there's too many steps that we're taking here. Let's skip to number 3. George is buying watermelons and pineapples to make fruit salad. He buys W watermelons at $4.49 each and P pineapples at $5 each. What does the expression 4.49W plus 5P represent? What do we say here? Let's go to Reagan. What do you say, Reagan?
Watermelon is pineapples.
Okay, so right.
Or the fruit, yeah, and we put it in the.
So we're taking so we're taking so every watermelon is $4.49, and we're going to buy W of those. So there's that 4.49W, and then we're going to have $5 per pineapple. We're buying P of those. So that if we put those together, what does it represent? It's an addition, so we're totaling.
How much or what?
Yeah, the total cost. Yeah, total cost for the pineapples and watermelons, or total cost for the fruit.
I think they think you're tricking them.
I guess so. I don't know. I don't know what I'm doing. That's scary. I don't know what I'm doing, right? No, hopefully not scary. All right, so let's try another one. Sandy buys 5 fewer packages of pencils than P packages of pens. Pencils cost $2.25 per package, and pens cost $3 per package. What does the expression 3P plus $2.25 times P minus 5 represent? What's this? Pens cost $3 per package, Pencils cost $2.25 per package. So what is this expression going to give us? Yeah, total cost for the pens and pencils. Okay, that's it. Okay. We're going to skip this explain section. All right, and we're going to go to some very important vocabulary words here. So on top of page 48, I'd like you to look there. Top of page 48. I dog-eared this. You might want to do the same. Okay, I dog-eared this. You might want to do the same. Okay, because it gives you our mathematical operations we're familiar with, right? Plus, subtract, times, divide. Okay, and it gives you the words that go with it. So if you see the phrase the sum of, added to, plus, more than, be careful with that too. When you see more than, you might think the inequality symbol, right? But that's if you see is more than is the inequality symbol, just more than by itself is addition. Increase by, total, altogether, and. Okay, subtraction, you can see there, again, you see that less than, it's not the less than symbol, okay? Less than, it would be is less than for the less than symbol. Just less than is subtraction. Okay? And you can use the examples here. Be careful with less than too. This one is very tricky. If you see 2 less than a number, you're tempted to say, oh, 2 less than a number, that's 2 minus n. N minus 2. Okay, so less than, the order flips around. So I'm going to put a little star on that one because it's kind of unique, okay? Watch the order for less than. Everything else is in the order. So 5 minus 3 is 5 minus 3, so on and so forth. But less than, flip around. Multiplication, you see your words there. Division, you see your words there. Okay, divide by, division. That one's pretty obvious, you'll see. Okay, so let's see this actually like in action here. Okay. Let's see here. So we'll see some examples here. Write an algebraic expression to model the given context. Give your answer in simplest form. So letter A, the price of an item plus 6% sales tax. Hey, what state has 6% sales tax?
Our state.
Our state does. Okay.
All states.
All states, not all states, but some states. Anywho, price of an item plus 6% sales tax. So price of an item, P plus 0.06p. Okay? So when you go up to the cash register, you give the person your item, they scan it, the cash register takes the price of the item and adds to it 0.06 times p for 6%, right? And so you can say that's your expression for the tax, or you can add together. That's 1p plus 0.06p, so 1.06. Price of a car plus 8.5% sales tax what do we want to use to represent the price of a car? What do you say? We don't know the price, so what should we use to represent it?
Variable.
Variable. Pick a letter.
Q.
Q. All right, that's weird, but you got it. Q. And then how do we do 8.5% sales tax? What decimal is that going to be? So let's take a look here. Hang on. Take a look up front. 6% became what? 0.06. What should 8.5% become then, Matt? 0.085. Yeah, so 0.085. Okay, and that's Q there. Okay. So the algebraic expression is Q plus 0.085Q or 1.085Q. Okay?
Does anyone understand where the 1 came from?
There's a 1 in front of the Q here, or a 1 right here. So 1Q plus 0.085Q is 1.085Q. Just combine like terms. Okay? Try number 9 and 10 at the bottom here. Try number 9 and 10. Okay, take the English there and write an algebraic expression for those. Okay, try 9 and 10 there. Try 9 and 10. See what you can come up with there. So read what it says. You'll have to come up with some variables. Actually, they need some variables, you're right. See what you can come up with there. Okay, 9 and 10. That's about on page 48. Try and come up with some expressions there. Question? Great. And then almost. So the original price less a discount. So original price less a discount of 15%, but it should be 0.15. What should go next to that? Not 0. P. Yep. Because you do 15% of the price when you take it off. So that's right. Good job. Okay. Question? Let me come take a look. Okay, so you're just putting like the label for the unit there.
Yeah.
I gotcha. And then what's the P here? Oh, per
minute.
So you don't need to do per minute. You can just do 35 times n, and that's fine. So just 35 m. So you can really just write 300 plus 35 and then equal to there.
And then you have
Nope, you were right. It should be a P in front, like you had there. And then here, this is close, but 50% of what? You need to have that, like you just have 50%. You need to multiply that by the original price. So it'll be P minus 0.15P. Like that. You see what I'm saying there? Okay. Do I see any other hands? Any other questions? I'll give you like 30 more seconds here. 30 more seconds or so. Okay, 30 more seconds or so. Call on some folks, unless you have questions. Okay, let's go to Erica for number 9. Did you come up with something there, Erica? Pass? All right. Let's go to Tyler C. How about you, Tyler C, for number 9? Whoop, right, yeah, it's Tyler. So Tyler C, my bad.
I did 35 plus M equals 300.
35 what?
Plus M.
Plus M?
Yeah.
Okay, so be careful. It's 35 gallons per minute for M minutes. We're actually going to multiply those two together. 35 M, and then, yeah, we're going to add 300. So you had part of it right, but it's 35 times M. And that'll give us then the number of gallons.
Added like 300 plus 35 m.
Sure, or we can have
I don't have to change.
that. Right, is that okay, right? If you do 2 plus 3, isn't it the same thing as doing 3 plus 2? So addition, you can flip the order around, it's the same thing. So yes, you're still right. Okay. You make sense now, Tyler? You're okay with that? Yeah? Okay. All right. Let's go to Hannah. Number 10, Hannah.
I did P minus 0.15P.
Great. Okay. So, great job, Hannah. That's exactly right. Many of us were able to get the P minus 0.15, but be careful. 0.15 by itself is not 15% of the price, okay? You have to do 0.15P, okay? It's kind of like the tax, but instead of adding the tax on, you're taking the discount off. So P minus 0.15P. Did anybody simplify this further? Okay, so you can, just like you do with taxes, you can leave, this is fine, but we could also say Since that's the same as 1p, you could do 1p minus 0.15p, and it would end up being 0.85p. So another way to say this is, if you go to like a store or something like that, and there's a 15% discount, that's the same thing as paying 85% of the original price. So you take off 15% of the price, that's the same thing as paying 85% of the original price. Okay? So it's a different way to think about it there. But you never really see that. Okay? Questions on any of this? So, for the remainder of class, I have an assignment for you on starting on page 49, and I'll write this on the board too. Okay? Page 49, numbers 1 through 13. Okay? And I'm also going to assign a few more problems from this dimensional analysis paper too. Okay, I'm just going to assign maybe like 1 or 2 more here. So then, and dimensional analysis worksheet. Okay, numbers. I'll have you number 3 on that paper. You like 16? Alright, what about 16? Just those 2 additional problems then, okay? 3 and 16.
Well, okay then.
Yeah.
Okay.
No, that's alright. I was looking at it too. I was like, alright. Okay. So get to work there. I'll come around and help you as necessary. Alright.